In this video, we will introduce you to DEM, Discrete Element Modeling. The Discrete Element Method, or DEM, is a powerful numerical technique that simulates systems of numerous interacting particles. By incorporating various types of forces acting on each individual particle, including the contact forces, DEM can predict particle flow dynamics and bulk solids behavior, such as segregation, flow patterns, or clogging, in a wide range of industrial and engineering areas. It is the method used by Ansys Rocky to process its particle simulations. When it comes to physics, DEM considers several forces that affect the behavior of the system, including contact forces, gravity, fluid forces, such as drag and buoyancy, electrostatic or magnetic forces, and additional cohesive forces, such as liquid bridging between particles. How does it work? The basic idea behind DEM is to represent a discrete set of individual elements that interact with each other according to specific rules. The motion of each particle is calculated using Newton's laws of motion, which relate the forces acting on a particle to its mass and acceleration. The core of every DEM code is to detect particle collisions and compute the contact force. With the soft sphere method, particles are rigid and any deformation at contact is modeled as an overlap. With the normal and tangential contact, the forces are computed as a function of the overlaps and physical properties of the particles. With the forces computed, the position and velocity of each particle can be predicted at the next time step. And, in cases where particle breakage needs to be considered, this can also be incorporated into the simulation. Another key factor is the importance of the shapes of the particles. In contrast to perfectly spherical particles, real particles can have different sizes and shapes within the same sample. And these more complex interactions affect the way particles interact with each other and the environment, ultimately affecting the flow and mechanical behavior of bulk materials. When two non-spherical particles come into contact, the contact force will depend on the orientation and shape of each particle at the point of contact. This means that the contact force cannot simply be computed based on the distance between the two particles, as is the case with perfectly spherical particles, and more sophisticated contact detection algorithms are required. Ansys Rocky has smart techniques for representing non-spherical particles, such as polyhedral and concave shapes. They increase the accuracy of the simulation, but it is worth noting that real particle shape modeling increases computational demand. And to finalize, here are some examples of DEM applications in different industries, such as mining and agriculture. In the food industry and pharmaceutical industry, using DEM helps on the optimization of processes. And finally, DEM is applicable in industries such as chemical manufacturing, oil and gas, energy, environmental engineering, and biological systems. To learn more about DEM, check out other Ansys Rocky videos and resources.